Today the topic is microstates. So if I define that microstates, then we say that it is the total number of possible arrangements of any given electronic configurations. So if you will given any electronic configurations, then what are the total possible arrangements? So that is called the microstates. This is also we can say that degeneracy. So the we say that this is total number of possible arrangements. Okay, so this we can calculate in 4 ways, like if the different cases, that what actually according to the questions there are the different formulas that we will calculate the total number of microstates. So let's see. So first let's explain this. So total number of possible arrangements of any given electronic configurations. Let's say we have that P2, or we have that D3, or we have that D1, like any electrons. Okay, so if this is given, so if see that p orbitals is like this, so this 2 electrons is given, so 2 electrons, that I can write this according to if I use that Hund's rules and above principle, all if I use, then electronic configurations I can do like this. And this also possible is there, that we can do different possibilities is there. Let's see, if I put like this one, or if I put like this, or I may also put so different arrangements are possible. Let's see like this dot 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 dot. So sometimes this one, sometimes I can put like this. So like this, so different way like that we can arrange. So like this we can arrange, lot of arrangements are possible. So how many arrangements are possible? The total number of possible arrangements, that is called the microstates. Likewise, if we calculate like this, then it will take long times and we may not conclude with a good results also. So for that we have to apply some formulas to calculate the total number of arrangements that is possible. So that total number of arrangements, that is called what? Microstates. Okay, so for this, let's say if it is P2, then for this the total number of microstates possibles are 15. Okay, so likewise we can go do this is 1 2 3 4 5 6 7, like that we will do 15 type of arrangements that are possible. So that is called the microstates. Okay, so for that some formulas are there. So what the formulas I use, how I understand that 15, I use the formulas. So if case 1, if you write case 1, if orbital is given, orbitals electrons are given and asked to find total number of microstates, then use this formula. Formula is n factorial, n minus r factorial into r factorial, where this n represent the total number of possible electrons in given orbital. Okay, so total number of possible electrons, and where R represent that number of electrons given. Okay, so let's say for if I say this is for p2, then here we see that this is p orbitals. So total number of electrons possible for this p orbitals, total number, I'm not saying about here R is total number of electrons, so R is number of electrons. Okay, and for n is total number of possible electrons, so total number of possible electrons is 1 2 4 5 6, means all orbitals has to be fully filled, that is called the total number of possible electrons. So here n is equal to 6. Likewise, if I say for d orbitals 3 4 5, so 1 2 3 5 6 7 8 9 and 10. So total number of possible electrons for d orbitals, this is p orbital, for d orbitals total number of possible electrons is n is here 10. Like that, if I says that f orbitals, then there is 14, n is equal to 14, like that. Likewise, okay, so n represent the total number of possible electrons, and where r represent that what is the number of electrons given in the questions. So here this p2, so if I apply that p2 in this formula, this is the way to calculate the total number of microstates. So if total number of microstates, this is the formula. Okay, so if that orbital electrons is given and ask that find that total number of microstates, then use this formula. Okay, so now if I apply this example for, if you take p2, then here if I apply calculate the total number of microstates, then that n, so here p, so for p orbital n is equal to 6, so I will use 6 factorial, and here r represented number of electrons given, so here 2 electrons is given. Okay, so I will use 2 factorial, and this is n minus r, that is 6 minus 2 factorial. Okay, so this if you solve it, then 6 minus 4 5 into 4 factorial, and this is 4 factorial, and this is 2 factorial. Okay, so you can cancel it, and this is 3, so total is 15. Okay, so likewise you will calculate the total number of microstates. This is the total number of microstate. So if orbitals electrons are given and asked to calculate the total number of microstates, then use this formula. Okay, this is the formula number 1. Now we will go for case 2. Okay, now if in this also another let's say this is A, then B case is also there. Let's see if that our orbital electron is like, let's say P1 and D1 is given. Okay, so here orbitals and electrons are given, so you will use the same formulas to calculate the total number of microstates, then ask to calculate total number of microstates. So total number of microstates, for this case how we will calculate? First for p orbitals is 3 and d orbitals 2 3 4 5. Okay, so here 1 electrons, here 1 electron is there. Okay, so here that n is equal to 6, here n is equal to 10, so you will use that same formula, n factorial, n minus r factorial, and r factorial. Okay, and another case, this is for p orbitals p1, another for d1. Okay, so here also we will use n factorials, n minus r factorial, r factorial. Okay, so if you get it, then for p1 n is 6 factorials, and for n minus r 1 electron is given, so 6 minus 1 factorial, and R is 1, only 1 electron is given, so 1 electrons, 1 factorial. And for D, that n is equal to 10, total number of possible electrons in d orbital is 10, so 10 factorials, and this is 10 minus 1 factorial into 1 factorial. Okay, so if I do it, then this is 6 into 5 factorials. If you solve it, then this is 5 factorials into 1 factorials into this is 10 into 9 factorials, and this is 9 factorials, and this is 1 factorial. If we solve it, then we will get this results 1 factorial. Okay, so this I will cancel. So how much remaining? This 1 factorial means 1. Yes, so this all are cancelled, so 6 5 ja 60. So total number of microstates are 60. Okay, so if that different orbitals are given, then we will also calculate the microstate by taking different way. For P1 one case and for D1 another case, like that. But if that same one orbital is given, then we will use this formula, and we will calculate how many electrons are given, and we will calculate this way. Okay, so now we will go for next case 2. If terms are given and asked to calculate the total number of microstates. Okay, so if terms, so we will in the next after some times we will discuss about what do you mean by terms, what do you mean by term symbols. For that, for calculating microstate, I am just giving that quick introductions. So terms, we can say that L and 2s plus 1, this is called the term. Okay, and so we will discuss detail about of this term and term symbols. And term symbols is 2s plus 1 and j. This is called term symbol. So we will discuss detail about of this. For time being, we will discuss only that things which are needed for calculating that microstates. Okay, so this L values, this is that let's say 0 1 0 1 2 3 4. So this for 0, L represent that S, and this is for P, and this is represent D, this is represent E, this is represents F. Okay, so now that if terms are given and asked to calculate, and this 2s plus 1, this S represents that spin multiplicity. Okay, so now if it is given any terms and asked to calculate the total number of microstates, then how to calculate the total number of microstates? Let's say if that example is, let's say any like says P, and this spin multiplicity will be written in the left hand side. Right hand side represent, if represent, then understand that this is electrons. But if it is represent in the left hand sides, then you understand that this is spin multiplicity. So let's say if it is represent 3, or let's say if it is represent D2, and let's say it represent that F4. These are the terms, because terms is likewise. Okay, so this is P, this is that L values, and this is that spin multiplicity. Okay, this is spin multiplicity. So now if this is given and asked to calculate the total number of microstates, then how will calculate the total number of microstates? For this case, that total number of microstates is, we will use the formula 2s plus 1 into 2l plus 1. Okay, this is the formula to calculate the total number of microstates if the terms are given. Okay, if terms are given and asked to calculate the total number of microstates, then use this formula. Okay, so for here the total number of microstates will be, so here the T, so you know that 0 1 2 3 4, this is S, this is P, this is D, this is this is F, this is G. Okay, so for this case, if I took it, then P is one value, so I will find this 2s plus 1, so terms is L 2s plus 1. Okay, this is the term. So this 3 represent that 3 is equal to 2s plus 1. Okay, so here 2s plus 1, so this is 3, so I will put here 3 into 2l plus 1, so P is there, P is equal to 1, so I will put that 2, and here L value is 1, so I will put 1 and plus 1. Okay, so according to the formula I will put it. Okay, so this P value represent that 1, D, if D is there, then that is represent D2, then just put the value of L here from here. Okay, and calculate the total number of microstates. So this is 3 into 2 1 are 2 and 1 3, that is 3, so total equal to 9. The total number of microstates will be, total number of microstates are 9. Okay, so likewise you calculate, like if that D2 is given, so here D value is 2. Okay, so formula if you put total number of microstates, that is 2s plus 1 2l plus 1. Okay, so 2s plus 1 value is given here 2. Okay, so this is the 2s plus 1 values, because term representation is L 2s plus 1, so this value is given to you. Okay, so that is 2 into 2l plus 1, so D here, D is represent 2, so 2 into 2 plus 1. Okay, so now this is 2 into 2 to 4, 1 is 5, 2 5 is 10, so total number of microstates are 10. Okay, so likewise we can calculate for 4f. So if any terms are given and asked to calculate the microstate, then use these formulas to calculate the total number of microstates. So this is the second formulas. Now we will go for third formulas. Case 3, if term symbols is given, and asked to calculate microstates, total number of microstates. Okay, total number of then what are the formulas for this? For total number of microstates, what you use the formula 2j plus 1. So this is the formula to calculate the total number of microstates, that is 2j plus 1. So if example case, if it is given that let's say D2 4, let's say F3 2. Okay, so for this if asked the total number of microstates, then total number of microstates is equal to 2j plus 1, 2j plus 1. So here j is this value is this, so because term symbol representation is, that is L 2s plus 1 and j. Okay, this is the represent of term symbol, so this j value we have to put here, so j value is here 4. Okay, so 2 into 4 plus 1, that is 2 4 is 8 plus 1, that is 9. This is the total number of microstates. Similarly, 3f2 is given. So total number of microstates, that is 2j plus 1. Okay, so here j is 2, so I will use 2 into 2 plus 1, that is 2 to ja 4, power 1 is 5. Okay, likewise we will calculate that if term symbols are given and asked to calculate the total number of microstates. Okay, now we will go for case 4. This way also they can ask, that is if Malkin term symbols are given to you, Malkin notations is given and asked to calculate total number of microstates. For this case, how we will calculate the total number of microstates is equal to, we will use the 2s plus 1 into degeneracy. Okay, this is the formula. So total, let's say if the example is given to you, let's say that what are the Malkin term symbols that we get, a either will be there, e will be there, otherwise t will be there. These are the Malkin notations that we studied in group theory, that a you have to use, or you may use b, or you may use t, or may use e. So this a or b is same, a will given or b is given. So for both the cases, that degeneracy, okay, for both the cases degeneracy is 1, and for this degeneracy will be 2, and this degeneracy is 3. So a or b represent the singlet, and e represent the doublet, and t represent the triplet. Okay, so these three Malkin notations are, anyone can be given to you and ask that calculate the total number of microstates. Okay, let's say if I take examples, let's say t to T2G, A3G, and E2G, whatever that microstate will given. For that case, what will you use? That formula is total number of microstates. So total number of microstates will be 2s plus 1 into degeneracy. Okay, so here 2s plus 1, this is that 2s plus 1, this value is given to you, 2 into degeneracy. For t, degeneracy is 3, for t degeneracy is 3, so we will use this one, 3 plus 2 into 3, that is equal to 6. Similarly, if you given the 3ag, okay, so for this total number of microstates will be, total number of microstates, that is 2s plus 1 value is given 3, so 3 into degeneracy for a is 1, so this value is 3. Okay, so likewise if that microstates, they ask you by giving these different cases, they may give sometimes terms, they may give sometimes term symbols, they given sometimes orbitals, electrons, they may sometimes gives you Malkin notations, and ask to calculate the total number of microstates. Then you can use this formula to calculate it. Okay, so if I give that sum of them, total number of microstates we want to calculate, by if that one case, if orbital electron is given, orbital electrons are given, this is one case. Then use this formula, that is n factorial n minus r factorial to r factorial. Okay, this is case A if one orbital is given, same orbital, or you can say that one orbital, and if different orbitals, like one orbital like p3, d4, d5, or let's say s2, p2, like that. Okay, and if different orbitals are given, like p1, d1, p3, s2, d4, s2, like that given, there for that total number of microstate formula will be n factorial n minus r factorial to r factorial into another times n factorial n minus r factorial into r factorial. Okay, this is for, let's say, p1, this is case for t1. Okay, so these are the if orbital electrons are given. Okay, now that next case, if terms is given, then use these formulas. Okay, if terms is given to you and asked to calculate the total number of microstates, on that case what you will do, 2s plus 1, 2l plus 1. Okay, and if term symbols is given, this is the 2 case, this is the 3 case, then we will do that. The formula will be, if term symbols is given to you, then that is 2j plus 1. Okay, this is the formula you will use. Now if that last case, that is fourth case, that if Malkin notations is given, then use this formula, that is 2s plus 1 into degeneracy. So these are the 4 formulas we can use. If they ask like accordingly the questions, you can use this 4 formulas. If they ask to they give the orbital electrons, then they want to ask the microstate, then you can use this formula. And if they once the different orbitals are given, then use this formula, this B case. And if terms are given, then use these formulas. And if term symbols are given, then use these formulas. And if Malkin notation is given, then use this formula, 2s plus 1 into degeneracy. Okay. So today up to this, we will discuss more in next class. Thank you.